Hello everyone, I hope you are doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is queue operations, and it is an easy level problem. So the problem is like fairly simple. They say that we have been given n integers and the task is to insert those elements in the queue, and also given m integers, and our task is to find the frequency of each number in the queue, right? So basically these are the integers that we have been given, and these are the numbers for which we have to find the frequency. So for example, if we talk about 1, so 1 is present 2 times in this whole particular queue, that is why we have to output 2. Now if we have been given 3, so we see that 3 is present here and 3 is present here, so it is also present 2 times. Now if we talk about 10, now 10 is not present, so we have to print -1, and the interesting thing is, like they have already taken care of printing -1, we just have to return 0 in case if it is not present, right? Now the thing is, the expected complexity of this particular whole question is n into m time complexity and O of n space complexity. Now you might think, right, why is it n into m? Because if we just have to output the frequency, right, so can we not just maintain a frequency array? And yes, I tried it and it will not work. I believe the reason is that the elements are up to 10 raised power 6, right? So you will be trying to create an array or a vector of size 10 raised power 6. But there are certain number of test cases, and for each of the test cases you will have to initialize that array or vector, right? So initializing is taking a lot of time, and according to the number of test cases it will not work, it will give you TLE, right? So I have tried it, that is why I am telling you. So I believe the overall reason why this question is framed like this is because they have written it on the top that they want us to learn operation on queues. So basically what you can do is, let me just take this particular example. One more interesting thing is that they ask you the query of second type. So these questions that you see here, these questions are only asked after inserting all the elements, right? So once all the elements are inserted, only then queries of this type will be asked. So basically what you can do is you can maintain a queue, or this might also work with a stack. It is almost similar, right? They can use the same question for stack as well. So there will be elements like 1 2 3 4 5 2 3 1, right? The elements are like this in the queue. So the thing with queue is you cannot just traverse the elements, right? The only thing that you can do is pop the element to see what is the next element. But if we try to pop this particular element, right, we will lose it. So we need some method to save this element somewhere. So one way of doing it is to use another vector, right? Use a vector and store all the elements in this vector. Or even better, if you don't want to use a vector, you can use another queue. You will take this element, push it into this new queue and remove this from here. You will take this element, push it here and remove it from here. Take this element, push it here and remove it from the original queue. So this is what you will be doing. Whenever you find an element equals to k is the element that they want us to search. So you will increment your count by 1, otherwise you don't do anything. So after all of these operations have been completed, your final queue will look like just like the original queue, and the original queue will become now empty, right? Since you do not want it to be empty, what you can do is you can apply the same operation. Since you have counted the elements, you can again do the same thing. From this copy queue or the temporary queue, you can move back all the elements into the original queue by using the exact same method, pop from here and insert into the second queue, right? So now your original queue will have all the elements which it already had, right? Cool. So this is all you have to do. You just have to move the elements from the queue into a temporary queue and then move back from the temporary queue into the original queue. The only reason why we are moving elements here and there is because we cannot directly access the elements of the queue, or we cannot directly iterate to the elements, right? So the only way is to pop the elements. So if we wanted to pop the elements, we cannot afford to lose the elements, because in that case our whole array will change, right? So this is why we have to maintain a secondary queue where we have to temporarily store the elements, right? This is all you had to do. This question was not much. I believe they just wanted to teach us push and pop operations on queue. So what we do is, in the insert function that we have, we just directly push the element k into the queue. So they are passing the queue by reference, so no issues with that. We will always get that particular queue, the same queue that we had. So we can just push this element into the queue. Now again, in the second function where we have to find the frequency, I create a temporary queue that is called p, right? Now I initialize my answer with 0. So while q has a size greater than 0, what I'll do is, so I'll push the first element or the front element of the queue into my temporary queue, right? And if the first element of the queue is equals to k, That means this is the element that I want to find. I'll increment my answer, right? And in the next step, what I'll do is I'll just pop the element from the queue. So now that I've done all of these operations, I need to copy back all the elements from the temporary queue into the main queue. So while the size of the temporary queue is greater than 0, I'll just push the front element of it into the main queue and pop it from the temporary queue. So after all of these operations have been completed, I've counted the number of elements, and I've also copied back all the elements from the temporary queue into the main queue, and then I can just return my answer. So I'll also show you that here you can see that they are getting the frequency, and if frequency is not equal to 0, they are printing the frequency, otherwise they are themselves printing -1, right? So we don't have to take care of this logic, right? And even if you do, it is not a problem, but they did it for us, so that is why I can just directly return my answer from here. So that is all about today's problem of the day. Now let me just quickly submit this code and show you that it works. So you will see that it passes all the test cases, right? So this code is absolutely correct, and I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to subscribe to this channel. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. And until the next video drops, keep coding, stay safe, bye bye.